Hello, today we are going to deal with air pollution control devices. Now, those are based on the sources control technology. Air quality management sets the tools to control air pollutant emissions. Control measurements describes the equipment, processes, or actions used to reduce air pollution. The extent of air pollution reduction varies among the technologies and measures. The selection of control technologies depends on the environmental, engineering, economic factors, and pollutant type. Now, the particulate control equipments are as belows: gravitational settling chambers, fabric filters, scrubbers, cyclone separators, electrostatic precipitators. Let's see first, that is settling chambers. Settling chambers use the force of gravity to remove solid particles. The gas stream enters a chamber where the velocity of the gas is reduced. Large particles drop out of the gas and are recollected in hoppers because settling chambers are effective in removing only large particles. Settling chambers are the devices that are introduced to the industrial exhaust system to remove solid particles from the emission. The particles, while passing through the chamber, settle over the settling trays under the action of gravity, thus cleaning the gas. Here you can see the entry of the gas and the exit of the clean gas, where at the hopper bottoms the dust is collected due to the heavy particle nature. Next, this is the settling velocity formula, that is Vs equal to h into V divided by L, where h is the height through which particulates travel before settling down. V is the horizontal velocity of carrier gas, L is the length of chamber, and Vs is the settling velocity of particulates. By Stokes' law, the velocity or the settling velocity is given as per the formula. The advantages are low initial cost, easy to design, low pressure drop, low maintenance cost, dry and continuous disposal of solid particulates. Disadvantages are require large space, less collection efficiency, only large size particles can be collected. Application: industrial application is limited, used widely for removal of large solid particulates from draft furnace, kilns, etc. Sometimes used in process industry, food and metallurgical industry. Used as pre-cleaners for high efficiency collectors. Next is cyclone separators. The general principle of inertia separation is that the particulate laden gas is forced to change direction. As gas changes direction, the inertia of the particles causes them to continue in the original direction and be separated from the gas stream. The walls of the cyclone narrow towards the bottom of the unit, allowing the particles to be collected in a hopper. The cleaner air leaves the cyclone through the top of the chamber, flowing upward in a spiral vortex formed within a downward moving spiral. Cyclones are efficient in removing large particles but are not as efficient with smaller particles. For this reason, they are used with other particulate control devices. Next is scrubbers or waste collectors. Scrubbers use a liquid stream to remove solid particles. In the scrubbers, gas laden with particulate matter passes through a short tube with flayed ends and a constricted middle. This constriction causes the gas stream to speed up when the pressure is increased. Here you can see the cyclone scrubber, where the cyclonic action takes place. Types of scrubbers: spray towers, venturi scrubbers, cyclone scrubbers, packed scrubbers, mechanical scrubbers. Now, choice of equipment. The choice of equipment depends upon the particulate size, particulate loading, efficiency required, properties of gas carrying, for example, composition, temperature, pressure, viscosity, density, humidity, combustibility, reactivity, toxicity, and electrical property. Next point or the next equipment is fabric filters. Fabric filters or bag houses remove dust from a gas stream by passing the stream through a porous fabrics. The fabric filter is efficient at removing fine particles and can exceed efficiencies of 99% in most applications. The selection of the fiber material and fabric construction is important to baghouse performance. The fiber material from which the fabric is made must have adequate strength characteristics at the maximum gas temperature expected and adequate chemical compatibility with both the gas and the collected dust. One disadvantage of the fabric filter is that high temperature gases often have to be collected before contacting the filter media. Now here you can see the vertical chambers or the tubular structure of filter bags from which the gas passes on and that is collected at the bottom in a hopper tube. Next is the electrostatic precipitator. It is also called as ESP, and ESP is a particle control device that uses electrical forces to remove the particles out of the flowing gas stream and onto collector plates. The ESP places electrical charges on the particles, causing them to be attracted to oppositely charged metal plates located in the precipitator. In the diagram, you can see the electronic precipitator arrangement. The particles are removed from the plates by wrapping and collecting in a hopper collecting below the unit. The removal efficiencies of the ESPs are highly variable. However, for very small particles alone, the removal efficiency is about 99%. Electronic precipitators are not only used in utility applications but also other industries such as cement, pulp and paper, petrochemicals, and steel. Economical aspects. Now let's see or compare all the equipments used. Cyclones, cheap to install, power consumption moderate, maintenance cost is normal. Whereas filters, expensive to install, power consumption is moderate, maintenance cost is high. Electrostatic precipitators, most expensive regarding installation, power consumption moderate to low as pressure drops, and maintenance cost is moderate. Scrubbers, installation cost is moderate, maintenance cost not high, high rate of power consumption. So depending upon the economical aspects, the equipments can be chosen as per the applications. Thank you.